try graphing this function on your own. So hit pause on the video, use a table, make a graph, and then replay it and see if what you graphed was correct. So what we want to do is set up our XY chart, just like we did in the last problem, and plug in numbers that are easy to take the square root of. 0, 1, 4, 9 again. So remember that negative 0.5 is the same thing as negative 1/2. So we should have gotten the y values 0, negative 0.5, negative 1, and negative 1.5. So notice that these y values are negative, so we need to do our graph a little bit differently. So hopefully you made a graph that looks more like this. So we had our first point at 0, 0, our second point at 1, negative 0.5. The next point is at 4, negative 1. And finally, our point is at 9, negative 1.5. All right, and we want to, even though maybe our points might be a little bit off, we still want to make this look like a curve. So what happened was we kind of got an upside down square root function. And that's okay. That will happen whenever we have a negative symbol out in front. So that doesn't affect our x values. So our domain will still be x is greater than or equal to 0. But our range, our y values, are different. Because this time, our y values started at 0, and they're getting smaller because they're negative. So we say that y is less than or equal to 0. In the next graph, our equation looks a little bit different because we have this plus 2 on the outside. Notice that it's not inside the square root. So let's make our chart. And again, we want to plug in the same numbers for x, 0, 1, 4, and 9, because those are very easy to take the square root of. So we have the square root of 0 plus 2, the square root of 1 plus 2, the square root of 4 plus 2, and the square root of 9 plus 2. The square root of 0 is 0, 0 plus 2 is 2. The square root of 1 is 1, 1 plus 2 is 3. The square root of 4 is 2, 2 plus 2 is 4. And the square root of 9 is 3, 3 plus 2 is 5. So let's make this graph and see what happens. So we have our first point at 0, 2, which would be right there. Our next is at 1, 3. And then we have a point at 4, 4. And then finally at 9, 5. So our square root function is going to look like that. A little bit different than the one that we graphed before, and that's because this plus 2 moved our graph up. So our domain, which is our x values, stay the same. It's still x is greater than or equal to 0. 0 is the smallest number we plugged in, and then they got bigger. But our range has changed. our smallest y value isn't 0 anymore, it's 2. And then the y values get bigger. So we have y is greater than or equal to 2. Now I'd like you to take a moment and pause the video and compare the last 3 graphs that we did with the parent graph, or the y equals the square root of x graph. The first one I'd like you to compare is the negative 0.5 times the square root of x. This next graph is y equals 3 times the square root of x. Oh, you know what? I'm sorry. These two should be switched, 4 and 5, but it really doesn't matter. We just need to compare. And then the last one was y equals the square root of x plus 2. So I'd like you to compare those 3 to the first graph that we did, y equals the square root of x. Hopefully you wrote something like this. For y equals negative 0.5x, our graph was upside down. Or what we say is reflected over x-axis. And it also shrank. For y equals 3 square root of x, this graph was stretched. The y values were much bigger. And for y equals the square root of x plus 2, hopefully you wrote something like moved up. What we usually say is there was a vertical shift. Now I would like you to try to graph some of these on your own. Pause the video, graph these 4 graphs, and then replay it to check and see if you graphed these correctly. This is the correct graph for number 1. Let's talk about its domain and its range. So the domain should be x is greater than or equal to 0, and the range should be y is greater than or equal to 0. On the next 3 graphs, try to label the domain and the range if you have not already done so. This is the correct graph for number 2. As you can see, the y values are negative. So this is a square root function that was reflected over the x-axis. So our domain stays the same as x is greater than or equal to 0, but our range is now y is less than or equal to 0. Here is the correct graph for number 3. Number 3 is a little bit strange because you need to take the square root first of the number and then subtract 1. That's how we get this 0, negative 1 point down here. So that's going to also affect our range. Our range is going to be y is greater than or equal to negative 1. Our y values start at negative 1 and then get bigger. This is the correct graph for number 4. Notice that, again, you take the square root of the number and then add 3 to it. So there was a vertical shift up. Our domain remains the same at x is greater than or equal to 0, but our range is now y is greater than or equal to 3. So give yourself a pat on the back if you got all of these or most of these correct. Good job. For this next problem, y equals the square root of x minus 4, notice that the minus 4 is inside of the square root symbol. This is going to be a little bit more difficult to graph because for this table, we should plug in numbers so that if you subtract 4 from that number, you can still take a square root. So we have to be very smart about what numbers we plug in to the table. So let's create a table right here. For example, we would not want to plug in the number 0. Because if we did so, we would take the square root of 0 minus 4, which would be negative 4. And we can't take the square root of any negative numbers. So we have to be smart about what number we can actually plug in. So can you think of a number that we can plug into this table? The first number I think we could plug in is a 4. Because we can take the square root of 4 minus 4. Because that's the same as taking the square root of 0. And that's okay. That would just equal 0. Can you think of another number that you can plug in for this table? The other number I think of is 5. Because if we plug in a 5, we're taking the square root of 5 minus 4, which is just the square root of 1. And we know that that equals 1. What's another number you can plug in? Probably not 6, because that would be the square root of 2. Not 7, because that would be the square root of 3. But we can plug in an 8. Because 8 minus 4 is the square root of 4, and that would be 2. Let's think of one more number we can plug in so that we can take a square root easily. Let's see. Would it be 9? Would it be 10? Would it be 11? Would it be 12? 13 is the next number. Because a 13 minus 4 is the square root of 9, and we know that that is 3. So, again, you have to be very smart about what numbers you plug in. Oopsies. For x. Let's try to get that table back up here. There we go. Okay, so now let's graph what we have. So we have to go all the way out to 13 on our x-axis. There we go. And only up to 3 on our y. Okay, so we have our first value at 4, 0. Our next value is at 5, 1. Now 8, 2. And then our last is at 13, 3. So now that is our square root graph. So this is different from the other ones because this did not move up and down. This moved side to side. So that is going to affect our domain. The smallest number we were allowed to plug in was 4. So that means x is greater than or equal to 4. For our range, our smallest y value was 0 and then went up from there. So we get y is greater than or equal to 0.